So now we are going to explain what is disjoint theory. Okay, so now we are going to explain what is disjoint uh, union disjoint theory. Okay, so what is union disjoint theory? Okay, so in union disjoint theory, there are we have this set 1 comma 2 and another set 2 comma 3. Okay, so what we are doing, we just make a leader of this set is 1 and we are make a leader of this set is 2, and if 1 is 3 or similar, if 1 is 3 or similar, then what we have to do, we just merge this and this set. How we can merge? We just make leader 1 and just make leader 2, and then we ask the 3, what is your leader? What is your leader? What is your leader? What is your leader? And we ask this from this set, that what is your leader? And it will say that my leader is 2, and it will say my leader is 2. My leader is my leader is 2. So when leader is same, then it will belong the same set. When the leader is different, then we merge the leader. Okay, what we are saying it, if here it is 5, like what? If here is 5 and we make the 5 is leader. Make the 5 is leader, and here 3 is leader. We make 3 is leader. We make 2 is leader. Okay, so 5 and 2 will merged if the leader is not same. Okay, so in the disjoint theory, we have a set like you can take 0 comma 2 this set, and you can take 2 comma 3. Okay, like you can take 1 comma 3. Okay, and we make 2 as a leader, and we make 3 as a leader. If 0 and 1 is similar, then we have to merge this 2 and 3. Okay, we have to merge this 2 and 3. I'm saying that if 0 is connected with 2 and 1 is connected with 3, and if 0 is connected with 1, then you have to connect 2 with 3. Okay, so this is our, if 2 is leader. Okay, so this is our union disjoint theory. I'm just telling you everything about this union disjoint theory. Okay, so just you can take this array. You can take this array. You can take this array initially. Okay, and we have many type of value like 1 comma 2 and 3 comma 4. Okay, so many type of value, 0 comma 2, 1 comma 1, 5 comma 5. Okay, so initially we take a parent array. Initially we take a parent array, and we made that every value is pointing itself. Initially every value point itself as a parent initially, but what we are doing is we just say that 1 is pointing to 2, this 1 is pointing to 2, so 2 is a leader of this set, and then we are saying that 3 is pointing to 4, 3 is pointing to 4, 3 is pointing to 4, and after that we are saying that if, what we are doing, we are just replace this with 2, and also we have to just replace 3 with 4, because 3 is pointing to 4, so there should be 4. Okay, and then what we are going, we want to merge this 1 2 and this 4 3 and 4. How we can merge this? We have to just put a 2 to 3 condition. So what is the condition? First we have to find a parent. So in here 2 is parent of this set, and here 4 is parent of this set. Okay, so how we can find the parent? We have just formula int find, and here we just send int f. Okay, and after that what we are doing, if parent of f equal to itself, then it return x. It means if any, like if 5 is parent of itself, then it will return 5. Like initially every value is a parent of itself. So if any value is parent of itself, then it return x. Else what we are doing, we just call a recursive call. What is recursive call? Return a parent of return find of parent. Okay, so return find of parent x, it means we just call the parent of x and then it will again call parent x till when we are not getting this condition. Okay, so this is our recursive call, and after that we have to make the pair. So when we are going to merge this set and this set, then we have to just we have a single function void union, void union, void union, where we just merge int x comma int y. So how we can merge this? We just find out the parent of x. We are going to find out the parent of x. So parent of x, parent of x. So we are going to find out the root parent of x. Parent of x equal to find x. So from here we just find out the parent of x, and then we just find out parent of y. We are just going to find out the parent of y. Okay. Then we are going to find out the parent of initially. So we are going to find out the parent of y. Okay. So when we are getting the parent of x and parent of y, then we are just going to compare it. Then we have to just go and compare it. If parent of x equal to parent of y, then what we have to do? We have to just return. We have to just return from that. It means if this is belonging from same pair, then you do not have to merge it. But if this is not similar, if this is not similar, then we have to make a parent of any you can make any leader, and then we create a new parent, and then we can make any of the leader. You can make 4 as a leader. When we make a 4 as a leader, then this 1 comma 2 will point 3, and then we put a 4 here 4, and here 4 also, because we made a new leader which is 4, and then 1 2 3 will point to 4. This 1 will point to 4, this 2 will point to 4, this 3 will point to 4. Okay, so every value is pointing to 4. Okay, when we are going to merge it, we can make any of the parent. We can make any of them parent. Like if we make parent of x equal to y, we can take any randomly. Okay, because this is a logically correct. Okay, we are not optimize it, but just put a value. In this union disjoint theory. Okay, so this is your union disjoint theory, but there are some constraints, there are some limitations. When we are going to find a parent, then you take a ON time. How? I'm just explaining this type. Like if this is our, like if 1 2 3 4 5 6, if 1 is pointing to 2, 2 is pointing to 3, 3 is pointing to 4, 4 is pointing to 5, 5 is pointing to 6. So the parent of 1 is 2, the parent of 2 is 3, and the parent of 3 is 4, and the parent of 4 is 5, and the parent of 5 is 6. Okay, so in this when you are going to find the parent of 1, then what we are going, you take ON operation 1 2 3 4 5 6. So you take ON time, and again when we are going to find parent of 2, then also you can take ON time. 2 is called 3, 3 is calling 4, 4 is calling 5, 5 is calling 3, and again you take ON minus 1 time, and then also when you are asking from 3, then it takes also ON minus 2 time. So it takes a ON time. Okay, it takes ON time. So it takes like ON square time. We take ON time to find out our parent. Okay, so every time this loop will run, because this recursive call will run every time. Okay, so this will take ON time to find. So this will take ON time to find our parent. Okay, so what we are getting, that the find function will take ON time. So the union function also will take ON time. So this will take ON time. So this also will take ON time. So okay, so we have to just reduce this. So we have to just reduce this time complexity. How we can reduce this time complexity? We just compress this path. We have to compress this path. And we can use a rank method. We have two method for optimize this solution. The first method is compress method, and second method is rank method. How we can compress the path? Every time when we are asking the parent of 1, then it will go to 6, and find out parent. And when we are asking the parent of 2, then it also go to 6 and find out parent. And when we are asking the 3, then it also go to 6 and find out parent. Every time this loop will run. What we are doing it, we just go in recursive call. We just go in recursive call, and when we are calling 1 to 6, then when we are calling the parent of 1, then it will run first time. Then it will run only first time. Then it will run only first time, and after that, when we are returning, then we are update the parent of 5 to 5, and we update the parent of 4 to 4, and then we update the parent of 3 to 6, 3 to 6. 1 minute. What I'm saying, when we are returning from that, then when in first time we are calling from 1, okay. When we are returning from 6, then we update the parent of 5 to 6, and we update the parent of 4 to 6, because the parent of 4 is 6 from the recursive call, and we update the parent of 3 is 6, and update the parent of 2 is 6, and update the parent of 1 is 6. Okay, so we are update the value at the time recursive call. What we are doing here, we just put here parent of x, parent of x equal to, like if we call the parent of x, then it will come, and then we just take the value. We just take the value of parent x. It means just what we are doing in that stage. We just erase this. We just erase this, and it will what we are doing here. We are just take a parent of x. Parent of x equal to find parent of x, and then we return this parent of x. Okay, so we are just update the value. Okay, and at the back, when you backtrack it, then we are just update the value and then return this parent. Okay, so what we are doing, we just return the parents and we update the value at the parent of 5. So we are compress the path, we reduce the time complexity. For 3 this is on, and for 4 this is on. For first time only we take on time. Okay, and for every step we just take on time. Okay, so this is our path compression for this unit disjoint theory. Okay, so after that, the second method is rank method. So what we are doing in the rank method? So in rank method, what we are doing, you can just check out that if this is our this is our matrix, this is our set, and like this, and also this is our set. 1 2 3 6 7 6 7. Okay, sorry, I'm creating wrong path, I think. This is our 5 and 6, and then this is 1, this is 2, this is 3. Okay, so there are what we are getting it, that if we are if the rank of 4 will bigger, what I'm saying, the 5 and 6, if this is our different set, if this is our different set, this is our different set, and this is our different set, and we have to merge this set, then what we are doing, we just find out what is the rank of this 4 and what is the rank of this 5. If the rank of 4 is bigger than rank of 5, then 5 will point with this 4. What I'm saying, if the 1 2 3 and 4 is different set, and 5 6 is different set, and we have to merge this set, then what we are checking it, we are going to check that if the priority of this set is higher than this priority of this 5 and 6, then it will point here. But if the priority of 5 and 6 is bigger, then what we are doing it, we have to point out this 5 and 6. This 4 will point to 5 and 6. But here what we are doing, we just find out what is the depth of this height. If the depth of this height is 4 and depth of this height is 2, then we have to point this, because we have to move that, because we have to reach that stage. When we are calling this 5 to 6, then we have to take an extra step, this plus 1 extra step. And when we are calling the parent of 1, then we take only 4 steps in this type of rank, in this type of merging. But when we merge this type, then we take 1 extra step. In this step, what we take only 4 steps, and this stage we are taking 5 steps. So this is good. When we are merging this type of stage, when we are going to merge this type of stage, then this is our good for. This is good because this is optimized. We are just taking 4 steps and here we are taking 5 steps. So we have to just check out what is our rank. According to rank, we are just update the parent value. So what we are going to do here, we have to just update our condition. I have to just make another condition. Sorry, I have to just write again. I have to just write again so that you are clear. So what we have to do is we have to just go and write again for rank method. Okay. No, I am just here. We are going to write else condition here. Okay. So we are just write else condition else. So this is your rank method. So what we are going to do, we just check out rank. If rank of our x is greater than or equal to greater than rank of y, then we just make a parent of y equal to x. Else if else if else if this condition, okay. And also what we are doing, else in this condition the rank of y is also bigger than the rank of x, so we just update the parent value of x equal to y. So we are doing the same thing, but if the rank of x is equal to rank of y, what we are doing when the rank of x is equal to rank of y, then what we are doing, then we just update, we just increase the, we just take a randomly parent, okay. We just take a randomly parent, like parent y equal to x, and we just increase the rank value of this parent, okay. So we just increase the rank value of x plus, okay. Only we are taking that thing only. When we are find out the rank of x and y equal, then we are just update the value of the rank, the parent, okay. So this is our 3 methods of union disjoint theory, okay. So I hope you understand what I am saying. So thank you.